K-map simplification. So K-map simplification, it is a technique used to reduce any Boolean expression. So we have namely three techniques for reducing a Boolean expression. So first one is using Boolean postulates or theorems. Next one is using K-map method, which we are going to discuss today. And the third one is tabulation method. So this K-map is also called as Coordinate map, and the tabulation method is also called as Quine-McCluskey method. So in today's class we are going to discuss mostly about K-map. This K-map is also called as Coordinate map. K-R-N-A-U-G-H, spelled coordinate, and coordinate map. Okay. Okay. So now getting into the coordinate map. So you should know what are all the different types of coordinate maps. That is, there we call it as single one variable K-map is possible. K-map. Then we have two variable K-map. Then we have three variable K-map. And then 4 variable, 5 variable K-map, up to 5 variable, even 6 variable K-maps in some cases is also possible. So for in today's class we will be discussing up to 4 variable K-maps. Okay, so we will be discussing single variable, 2 variable, 3 variable and 4 variable K-maps. So you know how the Boolean expressions are represented. There are various methods, like for example, so it will be Boolean expressions. Sometimes it can be represented as SOP form. In SOP form, so f of a comma b comma c is equal to a bar plus a bar b c plus a b bar c bar plus a b c. So like this your SOP form will be there. Sometimes it is also represented like this, that is f of f is equal to, in terms of 1 comma 2 comma 3, something like this. Okay, so like this it will be represented. So if you want to simplify these expressions, so this is a different expression, and this one is a different expression. So if you want to reduce this in terms of using K-map, you have to draw the terms, so draw the table, truth table. So here you can see, let us take this case 1 and case 2. Okay, so first we will see about case 1. So in case 1, So what is the steps? First you have to find how many variables this expression needs to be represented. So in how many variables is required to represent that function, that you have to identify. So in case 1, it is clearly, we know that it needs 3 variables. So namely, what are those 3 variables? A, B and C. Similarly, what about case 2? How many variables are required? Case 2, the required variables are, see here it is represented as, if you convert this in terms of binary, you will get 0 1, then 2 can be represented as 1 0 and 3 can be represented as 1 1. Okay, so it is nothing but 0 1 2 and 3. So what are all the terms are there here? It has 1 2 and 3. So in our equation, so it is 1 2 and 3. So what are the, how many variables are required? You need only 2 variables. So this can be represented as capital A and capital B. So again, now you know that these 2 terms are okay. So now if suppose now let us see what are all the steps involved in reducing a Boolean expression using K-map. So step 1, steps for reducing Boolean expression using K-map. So first step, you have to identify how many variables are involved. So you have to first identify the number of variables involved. Next, second step will be to draw the K-map. Next step will be to group grouping of the cells. Next will be the step to reduce the expression. So let's go to the step 1. Identifying the number of variables. So let us take one example. F of A comma B comma C equal to A bar B C plus A B C. So how many variables here involved? you can easily see that there are 3 variables involved in this. So A, B and C. So the maximum number of variables used are 3. Sometimes problem may have something like this: f is equal to min terms of 1 comma 2 comma 3, and then so if the function is given something in this format in terms of min terms, then what you can do is you can take the maximum highest number. So here it is 3, so you have to, using the formula 2 power n is equal to 3. So what is the value of n? You have to find the value of n. So n is equal to so greater than or equal to 3. Okay, so it should be 2 power n should be greater than or equal to 3. So n can be 2. So 2. So the maximum variables required in this case, you can directly check how many different literals are there. So using that you can find. But in second case, using this formula, that is this formula, you can find the value of n. So next, that is what is your step 1. So let us go to the step 2. So so step 2 will be drawing the K map. Okay, so drawing the K map, let us take this problem, this one. So A bar BC ABC. So it is a 3 variable. So for 3 variable K map, it should be something like this. Okay. Okay. So you will be having A, B and C. So this will be 0, this will be 1, so this will be 0 0 0 1 1 1 1 0. Always you should remember this thing. Here it will be 1 1. It will be in terms of gray code. So it will be in terms of gray code. So that is why after 0 1 you are having 1 1, and then after 1 1 we will be getting 1 0. Now let us map this one into this map. So A bar BC. So this one is A bar, this one is A, and here it is B bar C bar. This one is this cell, this row indicates your B bar C bar. This one is B bar C. This one is BC, and this one is BC bar. So now you can see our first term here, it is A bar BC. So A bar BC. So this one is 1. Similarly A BC. So A BC, here it is 1. So remaining terms, there are only 2 terms are available. So from this you can make a group. So while making group, you should make the adjacent cells, and there is some procedure for combining a group. So here this is a group. So what is this procedure for combining a group is that is, you can group the adjacent cells in terms of single cell, or you can group a pair, that is 2 as a pair, and then you can group 4 or the squad, and then octal. So 8 or 16. So you can see that it is generally following the these are the pairs recommended. Okay, so no other like for example you cannot make 3 cells as a pair as a group. Okay, so to avoid that you have to use only this one. So you can generalize this as a in terms of formula like 2 power again 2 power n. So where n is equal to 0 dot 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 dot, right, like this. So if you substitute different values of n, so you will be getting, when you substitute n as 0 you will get 1, and then if you substitute n as 1 you will get 2. If you substitute n as 2 you will get 4, like this it will be goes on, right. So this is generally following this formula 2 power n. Okay, now how will you select the cells? That is a bit tricky thing that I'll explain to you. Like for example let us take something, your K-map. After plotting the values, you imagine like for example let us assume a 4 variable K-map. So where 4 variable K-map, you know, that is, it will be having 4 terms A, B, C and D. So here A, B, and here it will be C, D, and you can have different cells 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 1. So this is for a 4 variable K-map. Okay, so this is for a 4 variable K-map. How we will mark in this? Let us assume that we are having a function something like this: ABCD 0, 0, 1, 1, or sometimes we can have equation something like this: A B bar C D plus A B C bar D plus A B C D plus A bar B bar C bar D plus A bar B bar C bar D bar. Some different combinations. Okay, this is just an example. Let's assume something like this. So you know, so the first term is A B bar C D. So you can see A B bar C D. So this will be your, so I will use some other color. So this term A B bar C D. So A B bar C D, this will be the first one. Then A B C bar D, A B C bar D. Okay, so this will be the second term, A B C D. So this one will be the third term. Wait, I made a small mistake. Just a minute. Zero zero 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Okay, now A B bar C D, A B bar C D, then A B C bar D, A B C bar D, A B C bar D, then A B C D, A B C D, this one. Then A bar, B bar, C bar, D. A bar, B bar, C bar, D. Then A bar, B bar, C bar, D bar. So something like this it will be getting plotted. So you can see again these terms are in terms of gray code, and this is also like a gray code. So now we have to draw the have to make a groups of these values. So which are all the things you can group? So you can group these two together. Okay, now similarly you can group these two together, and we can also group these two together. So these are all the techniques or methods of grouping. So what are all the so grouping is little bit tricky. So I will give you some tips for grouping the adjacent cells. So the what are all the tips, and similarly sometimes you will be having like this. So you will be having something like this. You can consider this all to be a group. Okay, so here this one, this one, this one, and this one, all these four together we can consider to be a one single group. And you have to imagine something like a truncation of this sheet. So truncation of the sheet metal in the sense, you can actually if you fold this, imagine this as a sheet metal. If you fold this, you can touch this part of your map with this part of the end. Okay, so by or similarly you can combine this with this. Okay, so it's something like truncation of a sheet metal. Or you can also imagine one more possibility like this. So what you can do is you can merge, combine this with this, and you can consider it to be a single group. Similarly, you can also merge so you can merge this one, you can merge this as this and this one as a single group. Okay, so these things are all possible. And then this software. Now I'll give you certain guidelines for grouping. So what are the guidelines for grouping? So always combine as many cells in a group as possible. That is, you should always give the preference to the largest group. You should try to cover as many cells as possible in a single group. That will be the our ultimate, that should be our ultimate aim. Okay, so this is the first guideline. Second one, make as few groupings as possible to cover all min terms. So you should also remember that you should have the number of groups should be as less as possible. So make as few groupings as possible. So the grouping should be as small as possible to cover all the terms. Okay, so the grouping should be as less number should be as less number of grouping should be as less as possible. Tip will be always remember, always you should begin with the largest group. You should always begin with the largest group, which means if you can find example, let us take an example. If you can group 8 cells together, it should be given preference. Okay, so if you can group 8 cells together, it is together is always better than grouping 2 groups of 4 cells. That is if you have the option like this, like for example, if you have something like this, you should give preference for making this together as a group. Okay, you should not, this is correct, but you should not group something like this. You should not do this thing. You should not group this as a separate group and this as a separate group. If you do something like this, it is wrong. This one is correct. Why? Because you should cover as many cells in a single group as possible, and similarly the number of groups also should be as less as possible. So that you should keep in mind. Now grouping is over. What is the next step, which as we have discussed? So what are all the steps we have completed till now? So we have first identified the number of variables. Now you know how to identify the number of variables involved. Next, you know how to draw the K-map. Next, we have seen what are the rules for grouping the cells. Now we have to get into this reducing the expression, how you to reduce the expression. Let us take this any one problem as an example, and then we'll be solving it. Okay, so let us take one example. Problem number 1. Let us take an example. So minimize using K-map. The given function will be given f is equal to a b bar c plus a bar b bar c plus a bar bc plus a bar b bar c bar. Now from this equation we can easily what is the first step? We have to find the number of variables used. So how many variables are used? Here you can clearly see all the terms are having the only a, b, c. So it is a 3 variable K-map. So first step 1, we have identified that 3 variables are used. Once you identified the number of variables used, next step is to draw the K-map. So step 2, we can directly go with 3 variable K-map. So 3 variable K-map, it will be something like this. So here we will be having a, b, c. So now let us plot this one. So this will be 0 1 0 0 0 1. Always remember it should be in the gray code. So 0 after 0 1 it will be 1 1 and then 1 0. You should remember this thing. Now you have to identify so this will be a bar a, this will be b bar c bar, this row, and this row will be column will be b bar c b c b c bar. Now plotting these values in this K-map, you will get a, b bar, c. So a, b bar, c will be somewhere over here. Second term will be a bar, b bar, c. A bar, b bar, c. Next a bar, bc. A bar, bc. Next will be a bar, b bar, c bar. A bar, b bar, c bar. It will be something like this. Now we have to, how many terms are there? One more. Okay, let's solve this one. Let us solve this one. So you have to group. What is this next step? Step 2. Step 3 will be grouping. So how will you group this one? You will change the color, so it will be clear for you. So this will be in one group, then this will be one group, and this will be on another group. You cannot group like this, that is you cannot group something like this, is not possible. Or the 3, that is this 3 is not, we cannot group. Why we cannot group? Because we know that it should follow the formula of 2 power n, that is the number of cells which can be combined. It can be it should follow this formula, that is it can be either 1 or 2 or 4 or 8 or 16. So 3 is not available and does not fall in this formula, so 3 we cannot combine together. Now you know how to reduce this one. So now taking each and every group and writing it, you will get A bar, B bar, C bar plus, that is, this is for, I am writing it for this group, first group, this one, A bar, B bar, C bar plus A bar, B bar, C, that is this term and this term I have combined it. Next, plus now I have to combine this cell and this cell. So if you want to combine these two cells, you will get A bar, B bar, C plus A bar, B, C plus, so now these two cells I have combined. Again I have to combine these two cells. So again I can write it as A, B bar, C plus A bar, B bar, C. So now I can reduce this expression using Boolean postulates. So A bar, C, B bar, taking A bar, B bar, just a minute, A bar, B bar, C bar, this should be A bar, right? Okay. So now rewriting this equation and taking common terms outside, so I can write A bar, taking A bar, B bar commonly outside, I can write it as A bar, B bar plus C plus C bar, plus similarly taking common terms in these two terms, I can write it to be A bar, C commonly outside, so I will get B plus B bar, plus we can reduce this equation, third one, which is taking common terms. So again it is B bar, C bar, this A, B bar, C, okay, this one, okay. So now writing common terms, I can write it to be B bar C into A plus A bar, so which will be A bar, B bar, so this term C plus C bar, you know, that is Boolean postulate, since X plus X bar is equal to 1, so this term becomes 1. Similarly this term becomes 1, this term becomes 1, so you can write A bar, B bar plus A bar, C plus B bar, C. Let's do one more problem. Minimize y is equal to A bar, B bar, so A bar B, C bar, D bar plus A bar, B, C bar, D plus AB, C bar, D bar plus AB, C bar, D plus AB bar, C bar, D plus A bar, B bar, C, D bar. So now what is the step 1? you know what is step 1. So you have to find the number of variables. So you can easily see that number of variables n is equal to 4. So you know how to draw the K-map for 4 variables. So for 4 variables should have 4 rows and 4 columns. So we'll be having maybe CD 0 0 0 1 0. So first term you have to plot A bar, B, C bar, D bar. So A bar, B, C bar, D bar. So I will use a different color. So this one, and then A bar, B, C bar, D. A bar, B, and C bar, D. Next A, B, C bar, D bar. A, B, C bar, D bar. A, B, C bar, D bar. This one. Then A, B, C bar, D. A, B, C bar, D. Next A, B bar, C bar, D. A, B bar, C bar, D. Next one is A bar, B bar, C, D bar. A bar, B bar, C, D bar. This one. Okay. So step 2 is over. That is, we have draw the K map, and we have also map the literals. Now what is the third step? Third step will be grouping. Okay, so grouping. In this, which are all the cells we can group? So the highest we have to give the there are no possibility for 16 cells, and 8 cells is also not possible. So we can give preference to the 4 cells. So here it is, can this as one group, and then you can do grouping of this one, and then you cannot combine this with anything else. Okay, so this alone is a single group. Okay, so this is what is your groups. Now let us what is this is third step is over. That is grouping is our third step, it's over. Next is fourth step. So what is the fourth step? Fourth step will be to reduce. So we have to write each and every term separately. So writing each and every term separately is nothing but first term. We can write this as A bar, B, C bar, D bar plus A bar, B, C bar, D plus A, B, C bar, D bar, B, C bar, D bar plus A, B, C bar, D. This group 1 is over. Okay, so now coming back to the group 2, this one you can write this to be A, B, C bar, D plus A, B bar, C bar, D plus these two terms are over. Okay, these two terms are over. Next one is this single cell which we cannot reduce, so it will be a bar, b bar, c, d bar. Now you will try to simplify these equations. So now taking the common terms outside, we can write a bar, b, c bar into d plus d bar. Similarly, these two terms you can see any common term, so you can write as ab, c bar into d plus d bar. Similarly, here we have a, c bar, d into b plus b bar plus last term a bar, b bar, c, d bar. So you know, since x plus x bar is equal to 1, so you can use that postulate and convert everything to be 1. So everything becomes 1. So 1 into anything, it is not going to make any change to the answer. So a bar, b, c bar plus ab, c bar plus a, c bar, d plus a bar, b bar, c, d bar. Now let us further simplify these terms. So you can see you can again take b, c bar commonly outside. You can write it as a plus a bar plus a, c bar, d plus a bar, b bar, c, d bar. Again, you know the same formula, can this to be 1. So the final answer, reduced answer will be b, c bar plus a, c bar, d plus a bar, b bar, c, d bar. So this will be your final answer.